right, everyone, we took a little bit of a detour, but now let's get back to statistics to our applied fit. So let's look at our data again, and then we had a nonlinear model fit. We can look at that. We can see how it plots. Let's do plot range all. So we can see those values and see the plots. And now we can see we have lots of statistics here. Adjusted R squared, ANOVA table, best fit parameters, et cetera, et cetera, et cetera. So you can get lost in this. So you could do and look at some ANOVA table analysis of your fits. But some of the more kind of common ones that we've looked at previously in here, let's look at we're looking at a random data set. So both of these, LM1, LM2, is a little bit of a worse fit, as we can kind of see. And we can kind of just confirm and plot that and actually look at some of the statistics that show us that. So obviously this linear model fit of you can just do this line plot. That's not a good fit. But we can confirm this with our ANOVA table. So for example, look at the p-value for this fit. 0.83 beyond it. So again, it's a very, very, very poor fit. You could look at confidence intervals between your fit as well. So again, somewhat decent for our MLL2, but look at the p-values here. So again, you're losing confidence effectively. You could look at R squared, adjusted R squares, and you can see very, very poor for our third R fit. You could do R squareds as well. And you can see we're losing some of the values there. And you can do the same thing for nonlinear model fits as well. So we are on the 2. Plot these. Oops, let's get them going. But one of the cool things you can do is actually you could use these functions to look at your confidence bands in your fit. So for example, if I want to look at my confidence or my prediction bands in my fit, I could use this function, pull out the mean prediction bands, and specify a confidence level interval, and plot them together. So the blue is my raw data, and then here, this yellow kind of width, as you can see in the blue curve, that's my, basically the width of my fits. And you could do the same thing for this plot here. So again, that's a 90% confidence interval. If I do 0.999, it'll change and it should widen up. So you see your width changes, especially based on your values. So again, you could look at, and again, there's a lot of values, and you could play around with all of these different fit statistics. And really, it's just kind of it's a little bit endless. So, but that's it. So hopefully you've learned about importing data, exporting data, extracting data, plotting data, doing some statistical analysis as you kind of lose your mind here, ANOVA analysis, and on how to do some fits. So we'll be doing our in-class activity, and then we'll see you next time for basically computer vision and image analysis. All right, thanks. See you all next time. Bye.